designed the motors, we designed the motor controllers, and all the software that went along with that. Motor control is a super interesting topic if you're into the very deep control theory. And then battery management is super interesting as well. It's not, I think in my hobby projects, usually I just buy like the little ICs that go on and manage your battery. But when you're working with big battery packs, so we had 100 battery cells in this product. The complexity of the battery management system gets quite a bit higher. That was a super interesting project. We also got to build a ton of these, and we sold them mostly to firefighters who couldn't afford helicopters but really wanted to fly aircraft. So this was like a really cool, it wasn't cool that this massive fire happened, but it was cool that we got to go out and fight quite a few fires alongside fire departments. The other cool thing about that project is we built a lot of those aircraft. And, this is from a few years ago now, but like we had, hundreds of these aircraft out in the world operating, which was really cool. And so we got to see some cool, data and software benefits from having just so many of these battery packs out in the world operating. And we started to do some cool, interesting machine learning things about like how do you do state of charge measurement and some of those like interesting topics which are hard to do with small data sets. Today, what I work on is actually kind of related to aerospace, though not like totally in aerospace, but it's ocean exploration. So the company I work at today, called Bedrock Ocean Exploration, is having the mission to map the whole ocean floor at a very high resolution. So, surprisingly to me, when I kind of started off on this endeavor, we don't have good maps of the ocean floor. Most of the maps that we have come from satellites, and it's, optically looking at the ocean floor and trying to figure out what it looks like. That's not very accurate. And if we want to be good stewards of the planet and do lots of cool projects, like, undersea internet cable needs really accurate maps of the ocean floor. There's lots of offshore wind projects that are happening right now, which need really highly accurate maps to deploy these massive structures out in the ocean. We need to have good maps of the ocean. Obviously, sending people out on boats to do this is not very cost effective. And you also can't get as close to the ocean floor. So my company today develops autonomous submarines that are relatively small. They're unmanned. They're about like 7 or 8 feet long. And they go out and map the ocean floor autonomously. So I've gotten to do lots of cool work. Also running on ARM, we work with NVIDIA. We use the Jetson processor set, and we use ROS. And so we're using very commercial off-the-shelf technologies to put together these awesome submarines to do really interesting work, collecting these super high-resolution sonar maps of the ocean. The ocean's a super interesting place to work in for autonomy because, a lot of autonomy work that's done today relies on GPS, which doesn't work underwater. The same thing for radio communications. Radio communications also doesn't work through water. So all of your communications and positioning locational stuff happens in the acoustic frequency, which is a really obscure and weird, but also fun and super interesting field to work in. So that's what I work on today. So that's kind of like a brief run through my career. I know that's super fast, but I'd love to answer any questions that people have in just a moment. What I wanted to touch on kind of at the end here is why do I think it's super compelling to work on aerospace or just these hardware projects in general? And I think the obvious answer is it's super cool. You get to do incredible, super cool work like this. But I think the more nuanced answer is that what I found is that we've got kind of a problem in the software engineering industry, which is that, I don't think that most people trust software to work. Me as a developer, I'm super used to, just restarting stuff all the time or I have to restart like my dishwasher software occasionally. I think like stops working pretty often, and I think society has kind of accepted that. And I think if we want to like have a really innovative future, we have to move past that. And aerospace is one of the interesting industries that it is highly motivated to solve that problem, because we must make it work or the consequences are super high. So yeah, I think that's kind of like my pitch of like why you should work on aerospace software, because normally the consequences of failure, you get this like cute like, oh no, things aren't working screen. In aerospace, I mean, this is kind of a grim example, but this is like the real consequence of failure. So in aerospace, you must make it work. And the challenging bit is that you have to do it today with modern software, which is working against you to do that. So like the example I always give people in other contexts is like, it's easy to visualize like mechanical things. So I talk about like a bracket. Like a bracket's like your simplest mechanical device. So like what is the bracket equivalent in software? It might be this like little bracket function, which is pretty easy to like make work. It's like, okay, this bracket holds stuff. The challenge of modern software is you have to take your bracket function and insert it into like a massive pile of brackets of other people's software, being like, Linux or drivers or like whatever you're going to use in your project, because it's so difficult to write everything from scratch and then make sure that works always, every time, which is super challenging, to say the least, but I think super interesting, and is really like, if we can figure out how to do that correctly as an industry, that's how we're going to start really making good breakthroughs and like having the future that we all want to live in. Cool. So that's my kind of quick pitch. I would love to take any questions people have now.
Great. Thank you, Keenan. Just to remind everyone about how you can submit questions. If you just enter questions into the chat box, we'll get to them as we go through. So Keenan, very popular. There's already lots of questions coming in, so I think you're right to get started on them. So first up, what's the battery life like on the US-1 drone?
Mm-hmm. So with no payload, kind of our target was 2 hours of flight time, which we thought was like the kind of the breakthrough number of like be really useful, because most drones are like 20 minutes or so. They're starting to get slowly and slowly better, but with the payload that we flew most often, we could do, I think, 78 minutes pretty solidly was the flight time, which we thought was awesome.
Great. Okay, next question. Can you talk a little bit about the tech stack used at Bedrock and at SpaceX? Are there any noticeable similarities and or differences?
Totally. So there's a really interesting, if you want to really dig into the tech stack at SpaceX, there's I think now 2 Reddit AMAs from the SpaceX software team that really get into a lot more detail than I probably can in the time here. So I would definitely go check those out if you can. The tech stack at both SpaceX and Bedrock, I think, is very different. SpaceX basically has written everything in-house. There's like not a lot that is coming from open source, with the exception of the Linux kernel. So like SpaceX, I think sort of famously is the only big aerospace company to run like the mainline Linux kernel, which is kind of like I guess like a debatable topic among the big aerospace companies. But everything's pretty standard there, so it's C++, Python, running on Linux. For the UIs, it's a lot of web technology. So, in Crew Dragon, which is the human spacecraft, they write all the displays and run them in Chromium, sort of famously, which is like kind of an interesting like reliability case of like how reliable can you make the web technology. At Bedrock, we kind of are going a different path. So we're based all on ROS there at Bedrock, but it's the same kind of thing as C++ and Python, working in the ROS world on top of Linux. So.
Next question. What is your insight about the future of programming languages, specifically in aerospace and high tech? And then what is your recommendation for a novice developer in this sense?
Cool. Well, so I have like my big picture concept of what I think is really the future, and like, I think that humans are highly graphically oriented. Nobody, I think, yet has created a compelling graphical programming interface, but I think really that is the future if we want to be conceptualizing like really complex programming systems. We need to be doing it, graphically, because software today is getting so complex it doesn't make sense to visualize a lot of it in a linear fashion anymore. And I think I've written a lot of LabVIEW kind of notoriously in my time, and that's one of the only working, graphical programming languages that has had success. I think it's kind of sad that it's closed source, and so it probably won't ever, achieve like totality, but I think really that's like the long-term goal. So like if anybody is actually working on that, I would love to hear about it. I think in the very short term, it's like aerospace, because of you want to be like fighting the least battles about are things working or not, and so usually people tend towards kind of like more boring programming language tactics. So like C and C++ are kind of the old standbys. Python is kind of gaining in popularity, but it's not necessarily suited for the real-time aspect of most systems. I think Rust is, it's kind of like starting to gain in popularity, and I think it'll probably get there in like 3 or 4 years. But if you want to be working, kind of today, like you can't go wrong with C, C++ for aerospace.
Okay. Next question. Would love to know about propensity of battery technology and how it can be used for nano-swarm bots on the surface of the moon. The biggest issue is certainly battery power for live computer power. How can we best tackle the battery issue?
Yeah, and batteries are a super big problem for sure. Like, obviously if somebody invented like a new great battery, that would be lovely. I'm not a battery scientist, so I can't make that happen. And a lot of smart people work quite hard on that. I think the best way to think about it is to try to just figure out what is the task that you want to be doing, and like how do you assemble a power system to do that. So luckily in space and in aerospace specifically, there's a lot of different options for how to do that. Solar is a big standby in aerospace, and for like something like working on other planets, there's a lot of nuclear options, which are possible because there's no humans around to have safety concerns about for nuclear. So most of the Mars rovers today are nuclear powered, and so there's a ton of different options. I think solar mixed with batteries is probably like gonna be the way to go, and then obviously try to get the power consumption of all of your robots down as much as you can. Yeah.
Okay. How will the advent of software that writes software impact the software that operates in extreme environments?
Yes.
A lot of software in that question. Did you
totally.
get that?
Yeah, I think I understand the question, and it's actually very similar to one thing that people talk a lot about is like, how do you think about like machine learning algorithms, for instance, in the context of safety critical or aerospace systems? Because a lot of the way that we decide if software is safe, kind of historically, is by looking at the software and saying like, does this seem safe? Like humans review it. That's sort of becoming not tractable, and it's not even really tractable for even existing software systems today. So like you couldn't do a line-by-line code review, for instance, of the Linux kernel. It would cost $1 billion is the estimate to do that. And so I think the way to think about it, which I've been pitching to people, is have a really strong automated test system for any software that you write, but also being able to start thinking about testing in a statistical method. So instead of saying like, we know this software function is certifiably safe because it meets these design criteria, having, like fuzzing is an interesting technical software testing technique where you can get statistical outcomes of like, is this software meet the constraints like 99.9% of the time or whatever it is. So I think thinking about safety and like testing certification from a testing and like statistics-based approach is the only way forward to think about those kinds of things.
Can you comment a bit on the software engineering methodology you use on aerospace, specifically to increase reliability? This is coming from a low-level software engineer.
Okay, cool. Yeah, so the way that I think about that is not so much a technical choice that you make. I think you can write really reliable software, basically in any proven technology, in any processor set, any language that has, the feature set that you want. It's more about like what is the end-to-end process that you do from like idea of software feature that you want to have to it running out on a real system. And there's a ton of steps, and like you have to do design, do code reviews, have a really good testing plan, test that on real hardware quite rigorously before you can put it out into a real system. And there's like a whole big process that you have to do. I've got another talk and article that I've published that's like linked on my website, or I can definitely send it to anybody who wants to read it. But it's called How to Write Safety Critical Software. And I think it tackles like more of some of the specifics of probably what you're looking for in that question. But I think there is like a pretty actionable flow of process that you need to do. So yeah, I can link in the chat here, but we can go on to the next question.
Great, thank you. Yeah, I was just going to say to participants, we can provide links after the call, so that's no problem. A great question here. Do you recommend Elon Musk's advice about working 80 to 100 hours per week? How do you get so much work done at SpaceX?
So I think there definitely is something to be said for working hard. I think, it's everyone's life. Like, you should design the life that you want. And for some people, they find a lot of fulfillment in working, that 80 or 100 hour weeks. So if you find that is a fulfilling and healthy lifestyle for you, then that's great. I think that most humans are not capable of doing that. And I think especially when you're talking, there's a difference between different kinds of work. So if your work is think heavily about the best way to architect this one safety critical software system, I think it's difficult to do that 80 to 100 hours a week, honestly. Because a lot of the work is done, in your subconscious, where you're thinking about the best way to kind of conceptualize problems, or you're talking with people and you need time to let ideas gel in. So it's kind of difficult to say what is working, but that's kind of my thoughts on it. So.
Great. I'll just remind participants about how to submit questions. Simply just enter them into the chat and we'll get to them shortly. This session is only meant to be for half an hour, but if we suddenly get an influx of questions, we can keep it running for a bit longer. But we'll see how it goes. So we've had one more question come in, Keenan. Could you name your role models in programming, if there are any?
Oh, sure. I have tons of role models for software engineering specifically. Most of them are some people that worked with before. So I'm not sure that naming them by name would be terribly productive. But I think what I would recommend if you're looking for this is like find a project. We live kind of in like the golden age of software engineering project information. Like there's tons of people out there, publicly and not publicly, who are doing awesome projects. Like find some of those people and just sort of like, try to learn as much as you can from them. Observe like how they work, like what about their work inspires you, and try to figure out how to work like them or like make your career like them. Most people love, kind of sharing about their experience and, sort of teaching others about like what they want out of the world and like how they view technology. And so I think if you've got ideas of projects, like, just start putting information out there and start getting feedback on it. I think you can probably find mentors who work just like you do. So.
And what was your education path like to enable you to get into the NASA program?
So I got a computer engineering degree. That's my undergraduate degree. I didn't get it from a very fancy school. Like I grew up in Missouri, actually, which is, I don't know, if you're from the United States, you probably know where that is, but if not, you might not. But it's like this nowhere state in the middle of the country. And I went to, a good tech school there, but definitely a public university, for sure. And so I just got, like a computer engineering degree, because for me it was the right interesting mix of like electrical engineering and software, and like how do you marry those two things. But I think there's really interesting opportunities, regardless of your background or, where you're coming from or where you are currently. There's tons of grants and contests and things that you can always be applying for and kind of putting yourself out there for to get into these programs. Interestingly, like aerospace and a lot of the really hard tech robotics programs are kind of undersubscribed. Like there's not enough engineers working in them generally, I think. So it's like if you are interested in that kind of thing, it's almost certain that there's opportunities out there. And like, if anybody is ever looking for like advice or a list of opportunities, I would love to, feel free to email me or like find me on Twitter or like whatever. I'd be happy to help you if I can.
Thanks, Keenan. And just to let everyone know, we put Keenan's Twitter details and his email address into the chat, so feel free to access details from that. Okay, a few more questions come in. Are there challenges specific to power electronics that have yet to be addressed on the projects you've worked on?
Oh, yeah. Power electronics is like not a solved industry or problem for sure. There's a ton. It's kind of like aerospace, it's like not, it's super important to all the electronics industry, but it's not super like sexy, I think. It's kind of like the most boring like electronics industry is the way that it's pitched a lot. And so like, I think it's super exciting. There's a ton of work like there. Motor controls are super interesting, not a solved problem at all. There's tons of people working in it. There's a lot of innovation to be had still. Battery management in general, like how do you charge and manage like multiple batteries? Like one thing I super recommend if you want to get into that is like go try to build yourself like a basic little solar panel battery charging system. Like go to SparkFun or Adafruit or like whatever it is and like, spend $75 and like get all the parts and try to build it, and you'll very quickly realize like, oh man, like there's a lot of stuff that could be improved here. From even the software side, like one thing that blows my mind for hobby projects is there's no easy like battery pack that has like a simple communications interface that you could like pull even like what the voltage of it is from an Arduino. So somebody made like a battery that you could connect to an Arduino and say like, give me the voltage of this thing easily. For hobbyists, it doesn't exist as far as I know. And so there's like a ton of work that people could do in power electronics.
Great. This might be one of the final questions. Did SpaceX implement the DO-178 software requirements?
Cool. Yeah. This one is, for those of you who don't know what DO-178 is, because it's kind of an obscure thing, that's one of the FAA's kind of like golden software standards for how do you write safety critical software for manned aerospace applications. There's been a few different versions of DO-178. So I think today we're on like DO-78D, which is like the revision number. Or maybe D hasn't been approved yet, and maybe we're still on C, and D is like a draft. SpaceX did not implement DO-178 to the letter. They did a lot of the same things that are in DO-178. Not exactly the same thing, though, because of, at least at the time SpaceX was getting started, you could not certify the Linux kernel against DO-178. That's where that $1 billion number comes from, is you have to do a line-by-line review of the Linux kernel to do that, and it wasn't possible for anyone to spend that amount of money. I think that's being addressed by the FAA now, so like DO-178 C and D have some provisions for things that are instant open source, which make it like a lot more tractable to do that kind of thing. But yeah, we need to know that. So.
Okay, and there is one more question that's come in. Is the LiPo fuel gauge on smartphone any good?
So I haven't used that one specifically. I think those are okay, but like, you just try putting it together. Like, you're gonna figure out all the problems with it. I think there's a lot of issues that like make it super. The barrier to entry is high still for somebody to act and then like make an Arduino with it. So yeah, like because you kind of have to understand from the software perspective, at least in my experience, like how do you reset the fuel gauge counter, for instance, like when you charge it, or like do some of the power switching when you like plug it in to charge while operating, for instance, is like the fuel gauges kind of start to not make sense at some degree. So I think there's still like that's a pretty good start or things to make that really accessible to kind of your average hobbyist coming into the domain.
Great, thank you, Keenan. I think we've come to the end of the questions. We've had lots of feedback, just looking through the chat now, just had lots of feedback, everyone saying thank you so much. So huge thanks to Keenan for hosting this session. This recording will be available on the DevSummit portal 24 hours from now, so people can still have access to the presentation shortly. Keenan, would you like to wrap up and then we'll close the call?
Sure, yeah. Thanks everyone so much for listening to me talk. Like I said, always reach out to me on email or Twitter, whatever. I'm pretty easy to find on the internet if you ever want to talk about anything. I also have kind of a new project that's sort of fun in aerospace that I've been starting. So the domain aero.space is a website that I now own and operate. And we're selling some like funny shirts and like merchandise and stickers and things on there. Turn them back to like a mentoring like grant program for people who, ideally who are in an underrepresented group in STEM who are working on cool projects in aerospace, and we want to kind of fund them and like get more people excited about building the awesome future that I think can exist. So definitely check that out if you're interested. So it's just, yeah, thanks so much.